Hey everybody, this morning, we're gonna do another quick video. They can only be 5 minutes, so, um, just quick, short and sweet. We're gonna talk about survivorship curves today. And from populations and demographics, we've been talking about like age structure, pyramids, total fertility. We look at a lot of human. But what we want to do is kind of go outside and look at population now from a perspective of looking at populations of bears and fish and amphibians. And so these survivorship curves are actually really helpful for that. And there's three types of curves, so it's real short and sweet, and we're going to just kind of go through them. So um, these are curves to show life expectancies of organisms. It's a way to represent age structure of a population. And the curve represents the number of survivors. So we're looking kind of at the survivorship, how long they live. So type 1 curve is late loss curves. These are mammals, so us. All mammals are going to be type 1. They're going to be common for K strategist. Now, this is a new term, and we haven't talked about this term yet. So a K strategist is a species that produces a few offspring, and they put a lot of time and effort into that offspring. And what they're trying to do is protect that offspring until it's big enough so that it can then become adult and continue the species, right? So humans fall right in that. Bears, dolphins, all of them, all your mammals. We're going to invest a lot of time. Sometimes it's going to be years, sometimes it's going to be months, but we do invest time. We only produce one offspring usually, sometimes 2 or 3, but it's a small amount. So these are going to be your type 1. And this is the curve for type 1. So they're born, they survive, they get to old age, and they die off. And this is just another view of the same curve. So that's type 1. Type 2 is a constant loss. So this is kind of intermediate. Think of birds. When you find a bird nest, you usually find like 4 eggs, 3 or 4 eggs. And out of those, maybe one might not hatch. The other 3 birds might hatch. Maybe one falls out of the nest, and now you have 2 birds. And 2 birds will grow up to be adults. So it's a constant loss. And some of those birds, like the one little bird, he's learning how to fly, and he doesn't fly right, and he dies. So now you have 1 bird, but it's a constant loss. So lizards, many birds, some small mammals would fall into this. And this is what the curve looks like. It's just a straight line. A straight line curve, okay? So that's type 2. And then type 3 is early loss curve. And this one is the exact opposite of type 1. So think about fish or cane toads, okay? Going back to our cane toads. These are going to be R strategists. Again, another new term. These are species that produce a lot of cheap offspring. No parent care on this one. So fish and cane toads works really well because you're going to drop 1,000,000 eggs, and you're going to hope maybe 10% of those get fertilized by the sperm that comes along, and maybe 10% of what's left gets actually comes to fruition, and then maybe 2 or 3 become a fish, an adult fish. So there's no parent care in the type 3, and their curve is going to be the exact opposite of type 1. And so this is what the curve looks like. You drop a whole bunch, but you lose at the very onset because there's no parent care. You learn a whole bunch. You lose a whole bunch. Okay. So then we often take all 3 curves and we put them onto one slide. So the next slide is going to kind of show you that. So here's one graph. Here's your type 1. Here's your constant loss type 2, and here's your sorry, I went too fast. And here's your type 3. So a mammal or a rhino or an elephant, your birds, and then fish or cane toads. And then here's another graph of it without the pictures, but again, examples here. But you will need to know the examples. You will need to know that this is type 1, this is type 2, and this one's type 3, and what these mean. Okay, so I did this really fast. You can go back and review it. And this is just kind of a short and sweet kind of survivorship curves, looking at kind of populations of